All right, welcome everyone. Welcome to Tony Wrestles with Multicast. Multicast is always fun. Um, Most of us don't use it on a daily basis, or even a weekly basis, or monthly basis, or yearly basis. Most of us, like myself, have only really used it when we're studying for exams or something. But one of the interesting use cases for Multicast is for a make sure my audio is working. Yep, it is. Okay. One of the standard use cases for it in the data center is to use it as an underlay for EVPN VXLAN. So there's two ways to handle BUM traffic: broadcast, unknown unicast, and multicast traffic. You can either do head-end replication, so the ingress leaf makes a copy for every other leaf that has that bridge domain, that VLAN on it, and then sends an individual copy to each one per device. So if I have 99 leaf, or if I have 100 leafs, and they all have the same VLAN on it, packet comes in, it gets replicated, we send 99 copies out. That can be an issue in really large scales and really heavy workloads. So the alternative is for that ingress leaf to encapsulate that BUM packet into a multicast group. And then the multicast infrastructure will handle the replication and then sending the frames. It's still going to be traffic on the wire, but at least the ingress leaf doesn't have as much work to do and doesn't have to clog up its uplinks with all this broadcast traffic. I mean, again, most of the time it really doesn't matter. But I am working on a cookbook for EVPN VXLAN configs and all the different varieties that you can do. Because you have a lot of choices when you're doing any kind of EVPN VXLAN network. And the choices are things like, choices. One of the things that you have a choice of is either head-end replication, or also known as ingress replication, or multicast for BUM. Broadcast, unknown unicast, multicast. It's not really unknown unicast because that's handled with the type 2 routes, and oftentimes with ARP suppression, which is on by default in Arista. So ingress replication and multicast for BUM. Then there's then you have to pick the multi-homing choice. So that's either MLAG or EVPN all active for multi-homing hosts. You've got those two choices. You've got your underlay routing, or you've got ISAS, OSPF, BGP for underlay. And it's also, you choose between either eBGP or iBGP for your underlay. And then you choose either iBGP or eBGP for overlay. For underlay, numbered or unnumbered. Even for BGP, there's a way to do unnumbered, or it's not really unnumbered, it's link local. But effectively, it's unnumbered in that you don't have to assign an IP address. Get my tea here. So these are just some of the choices that you got to make. And I've been working on building scenarios that work in each one of these. And then challenges. And multicast challenges. So there's been a couple of challenges that I've run into when trying to build these multicast configs, because the cookbook is a book of configurations that'll work. And to the best of my ability, I want to validate these configurations by running some tests. Like if it's head-end replication, I can just do a couple of pings, and that's pretty much it. But for multicast, I have to make sure that the packets were actually transferred via multicast and not by head-end replication. And I have to, the normal platform that I use for making these configs, which works for most of the features, does not support multicast. And it's not obvious that it doesn't either. And that's containerized EOS. So as far as I can tell, and I'm going to check one more time, but as far as I can tell, containerized EOS does not support multicast in the underlay. Another challenge is that AVD, which is a great utility for building configurations for Arista devices. It runs on top of Ansible, or you can run it just in raw Python. It's a fantastic tool to automate for automation. It also doesn't build multicast underlay configurations. So I had to come up with it on my own, find a way to verify it. And, there was, I wasn't even sure that virtual EOS could handle this. It looks like it can, because I don't have physical systems to try this on. So there's multiple challenges. One, CEOS, which I'm using with Container Lab, doesn't seem to support multicast. It definitely doesn't support it in the underlay, but again, I'm going to try one more time. It might support it in the overlay, so tenant multicast, which is a whole different subject, which I don't think I'm going to get into, at least in the first revision of this book. AVD doesn't build multicast underlay. Again, as far as I can tell, one of the challenges with the AVD documentation is that it has a ton of knobs, but it doesn't say if you want to do multicast in the underlay, here's what you do. Or if you want to do multicast in the overlay, here's how to do it for layer 2 and for layer 3, even with head-end replication. So lots of challenges there. Testing and verification. And there's a lot of documentation isn't available to the general public. There's a lot of good and bad things about documentation in the Arista world. One of the great things about Arista is they make the best virtualized platform for labbing. They've got VEOS and CEOS, so virtualized EOS and containerized EOS. And especially their containerized EOS is the best one by a lot. No other vendor has as functional and as close to the real thing as Arista does, at least that I've seen. And it's also really lightweight. So you can build out a fabric with these devices. I built a fabric inside of an 80 gigabyte VM that had almost 60 nodes. So leaf spine topology was 60 nodes running on an 80 gigabyte VM. And that was pretty fantastic. You could really show scale that way. The other vendors can't do that. Probably the worst I've seen is Juniper. And unfortunately, Juniper's they have a containerized Junos, but it lacks a lot of functionality. Their virtual switch VM is so heavy, it uses up a ton of CPU, just burns up a CPU, and uses up a ton of RAM. VEOS is actually not that bad. I thought it would be a lot worse. But generally, CEOS, for most use cases, is perfectly fine. It's great for labbing, but it doesn't do multicast in the underlay. So I can't use that for verification. And again, the problem is the documentation isn't available to the general public for a lot of stuff for Arista, and that's kind of a shame. I've got a generic account on arista.com, and there's not a lot it shows. It shows, the basic documentation is there, but their TOIs, their transfers of information, which are really good usually, they're not available to the general public, and I don't know why. It does seem silly that they don't share that stuff with the general public. You have to have an account and whatever, but you don't need you just need a basic account to get the CEOS and VEOS labs, which is fantastic. So good job on Arista for that, but I would like to see the TOIs be available to the general public too, because I don't have a business account or like a support contract or anything with them, because I'm just a freelance instructor. So this is try number 3 for me. I had trouble. I had a bunch of trouble getting everything to work, and I think I figured out what the actual issues are. And so we're gonna give it a try here. me log into my virtualized environment. So I've got it all to work for the most part, as far as I can tell. And the real trick is to see if I can do it again, to see if I can replicate it. And I think I figured out what I was missing. It was actually MTU. MTU was the problem. But
you sure about that? You sure about that? You sure about that?
Not entirely. So that's why I'm going to be doing this again from scratch, because I need to be able to do it pretty quickly, because I ran into some problems the day before yesterday on Wednesday, and I couldn't get it to work. And then I got it to work yesterday, but there was something like a generated config would work, but my config wouldn't work. But I think I figured out what the issue is, so I'm going to try it again, and then I'm sharing it with you all.
And who loves you? And who do you love?
Let's see how old the soundboard gets. All right, so the environment that I'm running. Which one am I using? Do I have it here? I'm using virtualized EOS in Container Lab, which is kind of weird. And we'll do this. Let's make it here. I thought I made it. Oh yeah, here it is. So I got a spine and 2 leaves. They're all running VEOS Lab, and I've got one VLAN that I'm stretching between them. And then the hosts are all my Linux containers that have the ability to do, I'm using iPerf to generate multicast traffic on the 224 range, which should be, it's not a routable range. It should be flooded to all endpoints on a given VLAN. And so far that's worked as a good way to validate. And there's a couple other validation methods I'm going to use. So I'm going to start over from scratch here and see if I can build this up. So to do that, so I'm not going to use AVD for this config. It's in the VOS directory. Then on CLab, so sudo docker, container lab destroy. So this is going to wipe out this topology. Oh yeah, need to do it one step above. Destroy. Wipe out the topology and then deploy the topology. So it just recreates it pretty quick. So the next thing I'm going to do is go into the hosts. So the hosts don't have an IP. The hosts, I've got 2 Alma Linux systems. They're not running SSH. So to get into them, it's sudo docker exec it host1 bash, and I've got to reinstall everything because it's ephemeral, so there's nothing saved. So like iPerf isn't there. I also have to install dnf-y install IP route, so that way I can set IP addresses and change the default gateway. dnf-y install iPerf. Oh yeah, dnf-y install. I don't know why I get that garbage there. Install. I need EPEL release. That's an enterprise Linux extended library or extended repos for enterprise Linux. And it has some extra tools in there like iPerf. And I think that's it. I think that's all I need. Oh yeah, I need to do IP. IP address. So I'm going to do IP address add 10.1.10.11 for Ethernet 1. I'm not going to change the default gateway yet. I do need to, because otherwise the multicast traffic will go over the management interface. I also want to change the MAC address. So that way things are easier to see. So that's IP link set dev Ethernet 1 address 020000000001. So the reason why I use 02 for the first octet is that's a prefix you can use on the OUI for the first byte of the OUI which is the first 3 bytes, which is this part right here. If you set the first octet to 02, it means that no other NIC in the world will have whatever address you put in there. So 02 is 02 is a locally administered block. So that means that no NIC will ever have something burn into it. So you're not going to run into a MAC collision there unless you configured it yourself or you do a device where someone else configured a MAC address. So I like using 02 as the beginning there. So 02, so that's good. So then we'll do this for host 2. So it's the same thing, which is DNF-Y, install IP route. Apple release, iPerf. Then set an IP address. So IP address add 10.1.10.12 because I'm just doing layer 2, just one VLAN. I'm not even going to route between the VLANs in this case. Dev Ethernet 1 and then IP address or IP link set dev Ethernet 1 address is 02.00.00.00.00.02. I really love setting MAC addresses for hosts so that when you're looking at MAC address tables, you're looking at EVPN routes, it's obvious what device you're looking at instead of just a jumble of, instead of alphabet soup of numbers. Because I want to make it easy for everyone to follow along what's going on because...
And who loves you? And who do you love?
That's a soundboard from The Running Man, the classic 80s movie that maybe more real life than we would like to admit these days. So, all right, so I'm set there. The reason why I did the host first is that because they're VMs, they take a minute maybe to boot up instead of a container, which is almost instantaneous. I'm going to make I'm working in the topologies, EOS lab. By the way, this box that I made is called the Auto Box. This VM that you're looking at, this is VS Code running as a web app on a Linux machine. So it's an Alma Linux machine. I've got all the instructions on how to build that on GitHub. I'm going to put a link to that build process. If you can make a virtual machine, and I'll put that in the chat room. If you can make a virtual machine that has 16 gigs of RAM and has 4 vCPUs or better, then you can build out a virtual machine that will have 2 spines, 4 leafs, and 1 external router and 2 hosts. So that's more than enough to lab almost any networking scenario using containerized EOS. You can do, you can do other platforms too as well from it, but it's got all the instructions to build that particular topology. It takes about 30 minutes. So as long as you've got a hypervisor and you've got enough RAM, got 16 gigs of RAM that you can use on a hypervisor and 4 virtual CPUs, then you can make this VM and all the instructions are there. One of the challenges I faced when I was starting this process was like finding a platform that was like easy to make and repeatable. And I wanted to reduce the amount of time because it took me days to build this, to build out the instructions. And it was, days I didn't have to spend doing it if someone else had done the work for me. So I did the work for you. Because I think one of the biggest impediments to learning network automation is finding the tools to do it. And this is a simple set of tools. There's plenty of tools out there, but there's not usually a complete set of instructions, or if there is, it's a pretty complex install with a lot of moving parts. So I try to make something with as few moving parts as possible. So the hosts are ready. And now we're going to go into the devices. Now, whenever I configure or troubleshoot an EVPN VXLAN network, the first thing you do is build out the topology. So in our case, it's already built. This is our topology. So the links are up, and I can go into the devices and verify, like show LDP neighbor. Oh, here's a thing you can install on Linux, and I highly recommend doing this. Is I'm going to go on to, let's go back to host 1. And I'm going to do dnf-y install ldpd. It's a lot of Perl to get that to work. And then that's it. Now I'm running LDP and host 2, dnf-y install ldpd. I don't know why that much Perl is needed. All right, so if I go into like leaf 1 now, now I can see that I've got LDP working. It just reports as MAC address as its port ID. Not sure why, but without that, I wouldn't see anything was connected on Ethernet 2. But that just makes things a little bit easier. So let's go to, now step number 1 is you build out the topology. So that's done. Step number 2 is you build out the underlay. The underlay is very simple, and you can do a variety of routing protocols. The underlay is to put loopbacks into the routing table. That's it. Or actually, no, let's make it more general. Provide IP connectivity between loopbacks. So spines are going to have loopback 0 and maybe super spines, and then leafs, loopback 0 and loopback 1. That's by convention. It's not part of the standard, but you generally will have some loopbacks, and I just use 0 and 1. Loopback 0 is used for EVPN peering, and then loopback 1 is used for VTEP endpoint, VTEP tunnel IP. I guess VTEP tunnel IP is a little bit redundant, but you get what I mean. So we're going to do the underlay first. And so I'll do it starting from the, and also in our case, we also need the underlay multicast. So that's an additional step, which includes, we're going to do PIM sparse mode, and we need a rendezvous point on the spine. So we only have one spine. We don't have to worry about any cast or anything like that. So we'll just do that. So we're going to leaf 1. So I'll do IP routing, turn on IP routing. I'll do interface loopback 0, IP address 10.1.255 is 1. IP OSPF area 0. We're going to use OSPF as the underlay routing protocol, because if you're labbing, it's the simplest. You don't have to assign IP addresses. It's easy to understand, and the configuration is the fewest number of commands you need to type for any of the underlay routing protocols. You could use OSPF, ISIS, BGP, but I like OSPF because it's so stupidly simple. We also need loopback 1, 10.1, 254.1, and then IP OSPF area 0. We'll do interface E1, that's connection to the spine. Verify that. Yep, connected to spine 1, also an Ethernet 1. And we'll do no switch port, turn on layer 3. IP address unnumbered, loopback 0. That's another reason why I love to use OSPF. It's because I don't have to worry about a numbering scheme. IP OSPF area 0, IP OSPF network point to point. And then we'll turn on router OSPF 10. We give it a router. We just give it a process ID. The 10 is locally significant. Doesn't get announced on the routing protocol whatsoever. We always want to set a router ID. So many problems can be set from that. And then if we can interface loopback 0 and 1 is passive. Passive interface. Passive interface, loopback 0 through 1. I think that's like the best practice, but it will work if you don't do that. All right, so I'm going to copy this, and then I can paste this basically into leaf 2. Although you got to be careful when you copy and paste. So loopback 0, IP address 10.1.255.2. Interface loopback 1, 10.1.254.2. And IP routing, and then just paste the rest of this. There we go. Oh yeah. And then interface, config mode interface E1, IP address unnumbered, loopback 0. Oh yeah, no switch port. All right, so I think that's it. So spine 1. Loopback 0, we're just doing loopback 1. We don't need, or sorry, loopback 0. We don't need loopback 1. And interface E1 through 2. Just verify that they're plugged into the leafs. Yep, they are. So it's no switch port, IP address unnumbered, loopback 0, IP OSPF area 0, IP OSPF network point to point, and router OSPF 10, router ID 10.1.255.101. I don't think I set one for leaf 2. That's why I gotta be careful with. Yeah, I set the router ID. This would cause a lot of problems because I copied and pasted in the same router IDs in both. That will cause problems. Okay. So if I go to SSH to spine 1, show IP OSPF neighbor. All right, so the second one that's going to, it's counting down the hold timer because it's not there anymore. So it'll go away in a second. If I had BFD on, it would go away immediately. So it's going to go away and it's gone. Okay. So I should see 254 and 255, 1 and 2. Yep, I do. So unicast underlay is complete. Now we need to do the multicast part. So I will go to leaf 1. And so it's router multicast, IPv4 routing. And then interface E1 is PIM IPv4 sparse mode. I think that's it. Leave 2. So it's IP config mode, router multicast, IPv4 routing, and then interface E1, PIM IPv4 sparse mode. Then the spines, or spine, router multicast, IPv4. Oh yeah, IPv4 routing. So it turns on multicast routing. Interface E1 through 2 is PIM IPv4 sparse mode. And then we also have to do router PIM sparse mode. And then what's the command next? Is IPv4 and rendezvous point. Oh yeah, I need to do interface loopback 10. IP address 10.1.254.101. That's going to be my rendezvous point. I need to be in the routing protocol because PIM will piggyback on that. Router PIM. Sparse mode, IPv4, and then rendezvous point is 10.1.254.101. Address 10.1.254.101. We're going to use 232 as the /22 as the what I'm going to use for PIM. So this was basically tells everyone 10.1.254.101 is the rendezvous point for that block of addresses in the multicast space, I believe. My multicast is a little rusty. Do I have that IP address? 254.101. Okay. And then I'll also go to leaf 1. Show IP PIM neighbor. Okay, that looks good. Show IP route. Make sure that I have 254.101 in my routing table, and I do. Good. So that because I have to be able to get to my rendezvous point. Oh yeah, the other thing I need to do is, this is what I think caused me issues, is MTU. So I want to make sure that my point-to-point links between my leafs and my spines have whatever my host will send plus 50 bytes. In this virtual environment, I'm not sure if 9,000 bytes will work. So I'm just going to have the host have their MTU set to 1500, which is the standard MTU. And in like 99% of the cases, that's what you want. So my fabric has to be able to pass packets that are 1550 because VXLAN adds 50 bytes. I think that was a problem I was running into. Let's check the hosts. And we'll see what the MTU is. Oh, the MTU is 9500. So I should probably set that. That is a big MTU. So 1500 for dev Ethernet 1. Oh, I guess that command on, I got it right on the first try. Cool. So I'll do the same thing over here. Go to host 2. IP link set dev Ethernet set MTU 1500 dev Ethernet 1. All right, so that should prevent some issues that might happen. I think that was a problem I was running into. Or T ASMR. So as long as I'm 1500 bytes or larger, 1550 bytes or larger, then I'll be able to pass all client traffic if the client traffic is 1500 bytes or less. They don't need to match. They just need to be whatever your host MTU is plus 50 bytes. Now, in most scenarios, most platforms, you're going to set it to the platform max, 9216 or 9214, depending on what vendor you're using, or something like that. Somewhere really high. As long as you did 9050, you would be okay in most scenarios. All right, what's next? So the underlay is complete. Now it's time for the overlay. So the overlay configuration, I'll do the spine first. Doesn't really matter which you do first. So router BGP 6501, router ID 10.1.255.101, no BGP default IPv4 unicast. So basically, we're not going to use IPv4 routing with BGP. We're just going to do EVPN because the underlay is the only thing that needs to route IPv4. Now, EVPN has IPv4 in it, so we're still just doing EVPN. And I'm using memorized topology here. So this is, I'm using eBGP for the overlay, and each leaf is going to have its own AS number. So I think that's it. Yeah. So neighbor EVPN peer group. Neighbor EVP. I'm doing all this from memory, by the way. This is how much I've used this stuff recently. Peer group. Update source loopback 0. eBGP multi-hop. Because eBGP sets the TTL to like 0 or 1 rather. On the spine, it's what is it? Don't change my local next hop unchanged. You don't normally need to do that. Send community. I think that's it. The neighbor 10.1.255.1 remote AS 65.101. Peer group. So inherit all the aspects of that. No, that's not what I wanted to do. AS 65.101. Okay, then address family EVPN, neighbor EVPN activate. So now it's trying to get access to those two, but they're not configured, so we'll just let that hang out for now. So router BGP 65.101, router ID 10.251.255.1. I think I can just cut and paste here. Down to here. And then neighbor EVPN remote AS is 65.0.0.1. Neighbor 10.1.255.101. Peer group EVPN. address family, EVPN, neighbor EVPN activate, show BGP EVPN summary. Established. First try. And I'll do that. So router BGP 65102. Set a router ID. It's 2, and then I can cut and paste the rest because they're identical. All right, so now the overlay is complete. So whenever you're labbing, whenever you're troubleshooting, whenever you're taking an exam, this is the order that I recommend people do things in. You get the topology, which is usually already set. You do the underlay first, and if you can't get the underlay to work, then you do not continue. You fix the underlay first. Don't continue on. Then you do the overlay. So now the overlay is complete. And maybe you should write down some verifications. Because again, this might end up being a class. So EVPN, VXLAN, build verification. So the topology, basically we're doing show LDP neighbors. For underlay, verify IP connectivity between loopbacks and verify neighbors for underlay routing protocol. Verify PIM neighbors for multicast underlay if you're doing a multicast underlay. Overlay, verify neighbors for EVPN. That's pretty much it. Now we're going to build the services. Oh yeah, build process underlay. Overlay is just peer for EVPN route exchange. And then we do the EVPN services, which is what we're getting into next, and that is things like stretched so VNIs, VLAN assignments, VRFs, and a bunch of other stuff. So we're ready for EVPN services. We're just going to stretch VLAN 2. It's going to be purely layer 2, no routing. Keep things nice and simple. So we're going to do interface. First, we put VLAN 10 in the VLAN database. Then we configure the port, which is Ethernet 2, show LDP neighbors, connected to host 1. That is going to be switch port mode access, switch port access VLAN 10. Show VLAN to verify. It's on Ethernet 2. Cool. Next, we do the data plane. I think the order doesn't really matter. So interface VXLAN 1. VXLAN update source is loopback 1. VLAN 10, VNI 10,010. I like using VNIs above 10,000 or anything above 4,000 really, just because that way we know when we see a number that it's not a VLAN, it's a VNI. But we've got a lot we can choose from. And then here's the magic sauce. This right here, flood group 232.0.0.10. That is what turns on the multicast underlay. So if we get any flood frames that we're going to flood, it'll be encapsulated into that group. And it means this leaf should now have done a subscribe to that multicast group, or join rather. So if I do show IP mroute, don't see it. Show IP PIM rendezvous point. Do I have one? Maybe I need to put it into the data plane. So we'll see. We'll complete and we'll see what's happening here. So show run interface VXLAN 1. So VLAN 10, we got to assign it to a VNI. Every VXLAN segment needs to be assigned to a local VLAN. So we've done that. Now, router BGP. We're going to do the MAC VRF. So that's just basically VLAN 10. We need a route distinguisher. We can auto set it. We need a route target. And we need to come up with a route target. I'm just going to use 1010, the VLAN ID. Or I could use 10,010, 10,010, whatever works there. We'll do redistribute PIM or IGMP. And we'll do redistribute learned. I don't know if IGMP, we need that, but I'm going to go ahead and add that anyway. Now, on my host, if I ping 10.1.10.1, shouldn't actually respond, but that should be enough to send an ARP packet up. So I can do show MAC address VLAN table VLAN 10, and there it is. So I've learned it. Let's see if I've generated a type 2 route. And I have generated a type 2 route. Cool. Let's see if the second leaf got that route. Because in eBGP, the spines are acting as route servers. They're propagating the routes. So show BGP EVPN route type MAC IP. Okay, so we got it. So we know where it is. So that's good. And then so show IPM route. So yeah, that's. Do I actually need to set? And we'll see. I might need to set PIM. Do I need to set the rendezvous point, or does that get sent through the routing protocol? I don't know. Again, my multicast is kind of weak. All right, so to do it over here, so interface, or sorry, VLAN 10, put it in the VLAN database. Interface VXLAN 1, VXLAN source loopback 1. VXLAN VLAN 10, VNI 10,010, VXLAN VLAN 10, flood group 2320010, then router BGP, VLAN 10, RD auto, route target 1010 for both ingress in and out, redistribute learned, redistribute IGMP. That should be enough. I should be able to ping between host 1 and 2 now. Oh, I have to configure the port. Interface E2, switch port. Switch port mode, access, switch port access, VLAN 10. Now I should be able to ping. I take a second to ARP. I only see my local one in. I see the. So this is the MAC. This is the route. Oh, there it is. Okay, so just took a second to install into the tables. That's pretty normal for this virtualized platform. So I've got good connectivity between the two. Question is do I have show IPM route? Ah, there we go. So now we've done a join. So I didn't need to. Moment of truth right now. This whole thing has been about building a configuration that could do multicast in the underlay. So I'm going to do this. Show BGP EVPN route type IMET detail. So PIM SSM tree. So that means that I am using multicast in the underlay, or at least the routes are saying to join a multicast group. GMP proxy. Okay, so, and then that's the multicast group right there. So when a flood frame enters the ingress leaf, it should be encapsulated into a multicast destination address sent to the multicast group. The spine will then, doesn't have to duplicate anything. It just sends them one copy because it's there's only one other leaf. Moment of truth is I'm going to use iPerf. So look up iPerf multicast test. There was, yeah, basically I was using this the whole time. So on host 1, I'm going to join the multicast group of 224.0.0.100. And so that should get flooded everywhere in the VLAN. Technically the term is bridge domain, but we're just going to use VLAN as the term. So 224.0.0.10, 100 rather. All right, so moment of truth. Will this work? Ah, thank goodness. It works.
Actually, it's going to be super easy, barely an inconvenience.
So that's for a relief. My third try, I was able to build out a configuration that has multicast in the underlay. Actually, no. Before I get too excited, I'm going to do this. So show interface, clear counters, show interface counters, and I'll do watch 1, show interface counters. I love the watch command. And we're going to see if the packets come through as multicast, because it'll get encapsulated as a multicast packet, then sent up to the leaf, or sent up to the spine. So we should see in and out multicast packets increasing when I run this test. So let's run it again. I ran into this problem yesterday. It's going over the It's going over the. It's the default gateway on the host. I forgot about that. The reason why I didn't change it is that if I need to add more software, it can't connect out to the repos. So I have to change the gateway. IPR for IP route. We see that it's sending everything out Ethernet 0. So all the multicast traffic went out the management interface. So of course it worked. So I'll do IP route delete default, IP route add default device Ethernet 1. Since I don't have a gateway, but I can still point it to an interface. So IP route, and we can see that that's there. All right, do the same thing. I'm glad I verified this because I would have been like, oh, I'm super smart. And not realize I'd made that mistake. So always verify. IP route, delete, default, IP route, add, default, dev, Ethernet 1. So let's try that one more time with feeling. UDP setting a multicast server and multicast client. Still works. Now let's see what we see here. Oh, look at that. Let's do a lot of traffic here. All right, this is what we should be seeing. The packets are coming in from leaf 2, which is on Ethernet 2, and they're going out on Ethernet 1, which is the leaf 1. So that's what we're looking for. So we verified and it works. I could probably do more specific verification. I could see if I could TCP dump on the host. No, on the leaf or on the spine to see what the source and destination IP addresses are. So I'll go to bash. And what is my... Looking for my IP addresses that have... Nuts here. Because I did IP number, I've kind of screwed myself. All right, so I'm looking for, I think this will be the right interface. F2 double delta. F2 double delta. Okay, so Ethernet 2. So IP, IPA. So I want to do TCP dump dash I Ethernet 2, F2 double delta. Can I just specify multicast? It's been a while since I used TCP dump. TCP pump dump. TCP dump filter multicast. All right, let's try that. Ethernet 2 doesn't exist. Is it ET? Is it 18 by the index number? F2 double delta. No, that's 17. Not seeing anything. I didn't see anything there. F2 double delta. Oh, 16. It's 16. Oh, there we go. Hello. Yeah, there we go. Look at that. It's cool. It actually it worried me for a second there because I'm like, I'm seeing the inside packet, but you know, here's the outside packet. It shows us both. Well, that's kind of cool. I didn't know TCP dump did that. So this is the loopback 1 address of leaf 2. This is the multicast group that it's sending to. So yeah, we have verified this to the best of my ability that this works. Now, do I want to try this on containerized EOS? I'm almost positive it doesn't work, but I may want to just do a double checkaroonie on that. But for now, well, not for now. Right now, I'm going to do a tea break. I'm going to make some more tea. I'll be right back. Oh, it feels good when you struggle with the config and you finally get it right, and everything is great. All right. Actually, I want to do one more thing before we switch over. I want to check the behavior of a different configuration. So on my Leafs, I'm going to switch it to another command. So no VXLAN VLAN 10 flood group 232.0.0.10 VXLAN VLAN 10 multicast group 232.0.0.10. I'll do the same thing over here. On Leaf 2. So we're doing multicast group. Now, if I do show BGP EVPN route type, IMET detail, we see that the tunnel is now ingress replication, and we don't have an IGP group. So this should be taking our broadcast traffic and then putting it into, it's encapsulating it via ingress replication. So it's still working. Let's see what we see here on the filter. Yeah, so we don't see any multicast, just some PIM hellos. I would see more traffic. I'm not sure what. That's unicast. You can see the traffic flowing. And FF double delta, that's Ethernet 16, so TCP dump -I 16 -N, so don't do a reverse lookup. All I'm seeing is the multicast traffic. I'm not seeing any of the encapsulated. How do I specify UDP? Maybe that it doesn't do UDP by default. TCP dump. It's been a while since I've worked with TCP dump. -U. Maybe. The BGP. Maybe. I don't know why we would see that traffic. It is a virtualized platform, so sometimes weird stuff happens. It's definitely going through the spine, and I'm on the spine. Am I on the spine? Yeah, I'm on the spine. Maybe I should sniff the loopback. Or one of the fabric addresses. Yeah, 7. Maybe I should 7. Nothing there. What about 254.101? Where's 254? 21. So let's try 21. Oh, there we go. There she blows. So, yeah, it's probably just some weird internals about Linux and how it's handling it in the virtualized environment. So I'm satisfied with that. So, cool. That works. And let's go to a... Oh, yeah. One thing I want to do is I want to make sure I back this up. So now I've got a copy of the working configs. How much memory am I using up? Let's check out HTOP. Not too bad. I thought I would use up more. All right, so I'm going to go ahead and destroy this environment. I've got the configs. I can just upload them if I need to. Sudo container lab destroy. I'll go ahead and deploy this one. This is the standard topology. 2 spines, 4 leaves, 2 hosts. Did I change it over to... I changed my host to Linux. Nope. So I'm going to do what I did with the other one, which is EOS, which I'm instead of normally I was using just EOS containers as hosts because they were easy to configure for like things like LECP and link aggregation, but they're not great at doing verifications. So I'm just going to copy and paste this over here and change them over to Linux containers. There we go. So we're just double checking to make sure that it doesn't work on Container Lab. I don't think it does. And that's fine. I mean, it's containers, the networking in containers is pretty complicated. It's pretty impressive Arista was able to get as much as it did to work in a container. because for most of the VXLAN functionality in unicast, it works just great. But the multicast parts, that's where you need at least VEOS. All right, and so let's just go into the hosts. So it's because I don't think I can. Yeah, host 1. Yeah. Sudo docker connect or docker exec it host 1 bash. So dnf-y. There's a way to automate all this, and I just haven't gotten around to figuring it out. But IP route. Apple release. And I need iperf and LLDP. LLDPD. LLDPD. Yeah. It's kind of a mouthful. Kind of a handful to type as well. PA on host. Oh, jeez. How did I end up with so many interfaces? I think it's interfaceception. We'll do IP address add 10.1.10.1.11 on dev Ethernet 1. IP address or IP link set or dev 1 set address. IP link set link dev Ethernet 1 address 02. Oh, cool. Got the syntax right the first time. I also could use Ansible, but LDPD. Route and iperf. IP address add 10.1.10.12 to Ethernet 1. IP link set dev Ethernet 1 address. Okay. Now, and there we are. So looks like we're good there. Oh, that's right. They have 2 connections there. We'll go through it again. The basic configs are there, but none of the underlay is not, or the topology is complete, but the underlay, overlay, and EVPN services are not configured. Should just take a few minutes. I can go in and kind of steal some of this stuff. So I think most of this would work. I'm just going to do one spine. I don't have to do 2 spines for this. All right, that should be enough for the underlay for leaf 1. I have a shortcut here. Nope, no, never mind, I don't. Spine 1 working. Three, 4, 5. Yeah, 3 and 5. Because I'm going to do it on leaf 1 and leaf 3, not leaf 1 and leaf 2. Oh, this is not an Ethernet 1 either, man. Cutting and pasting is fraught with peril. So that should be good there. Yeah, where are they coming up? To spine 1 show interface E1. Ethernet 3 is connected to leaf 1. MTUs are the same. Oh, IP routing. There we go. And set up OSPF. And should do router multicast as well. To leave 3 is connected on Ethernet shot 5. 5 should be connected, so there we go, full. Show IP route. Need to make sure that I see all the routes for all the things. Okay. Two 254.101. Yep. Okay. So the underlay looks like it's complete. So for multicast and unicast. So we're good there. Then we'll do router BGP 625.101 for leaf 1. I think I can just copy and paste this entirely in its entirety. Same thing over here. And then the spine, same thing. All right, overlay is complete. Now with just EVPN services, so this is a pretty quick build. Almost done here. So let's do this the old-fashioned way. So you can imagine why we always recommend automation with EVPN VXLAN, because there's so many moving parts. Maybe I'll just cut and paste a little bit here. On leaf 1. Flood group 232.0.0.10. Then got to configure the port. Okay. Over here, we'll do it the other way around. Oh, did I not turn it on? There it is, Ethernet 10. All right, so that's there. Okay, I think that's good there. And then just the interface VXLAN part. Flood group 232.0.0.10. All right, so I should be able to ping 10.1.10.12. It might take a second for it to get programmed into the forwarding tables. Show MAC address VLAN 10. I don't see the other MAC. All right, now I see it locally. So I see both MAC IPs. Installed in the forwarding table. So the routes are getting to the devices. Ten 2010, 2010, 2010, 2010. Oh, it may be that because the ARP's not even working. I wonder. But then it should have installed that's all it needed though. What do we see here? So if I do IP neighbor, yeah, it can't ARP. But we should have ARP suppression on, so it should be proxy ARP. Yeah, it's so yeah, multicast doesn't work at all. That's weird. I thought it would have worked. Let's try going back. Now that the ARP is done. No, yeah, we don't have VXLAN there. All right, put it back on. Actually, no, we'll do this. We'll do multicast group. See if that works. works. Now we're going to check route delete default, IPR delete default, to route add default dev Ethernet 1. Try that multicast thing again. So that's the server, and then this is the client. All right, well, that actually worked. I didn't think it would work. So that kind of multicast does work. So let's do... Let's try reversing it. I'll do a different multicast group ID just to check the IPM route. Maybe you do need a... I didn't set a rendezvous point, but I didn't need to before. The flood group. All right, so we're both are joined. So at least they found it, so maybe you don't need a rendezvous point. That one I set before. All right, so that's joined up there. Yeah, it's not working. All right, yeah, I think with I think it's safe to say that in Container Lab, multicast in the underlay doesn't work, but it does work in VEOS. So at least I got that going. So I'm going to go ahead and wrap up this. Made a lot of progress today. I mean, I'm sure most of you have been in a situation where you're trying to get something to work and it doesn't work, and you're trying and trying and trying, and you're not sure if it's even supposed to work, and sometimes the documentation's not quite clear, or you don't have access to the documentation. But we got it sorted out. VEOS, I've got a good working config, so I can continue on with the book. If you've been watching this long, thank you for watching.